Good morning everyone and welcome to our presentation. First of all, let us thank you all for taking time to watch our presentation video. Let me introduce myself. I'm Phakphoom Methawansasukul and I'm here with my team members. They are Affan Wasu, Suthat Palerb Lam, Suwarnachat Yansuwan and Ekadat Putsiri. We are third-year students from King Mongkut Institute of Technology Ladkrabang or KMITL in Bangkok. The topic of our presentation is the magnetic fields, properties, and constant torque of the induction motors. The induction motors are widely used as industrial drive because they are self-starting, reliable, and economical. The single-phase induction motors are used extensively for smaller loads such as household appliances like fan. Although traditionally used in fixed-speed service, induction motors are increasingly being used with variable frequency drive that we know as VFD. Therefore, we choose this topic to study the motor's control, and it might be useful data for the engineering student to work in the future. This presentation is structured as follows. First, we will give you an overview of the theory about motor control. The second, we will tell you about the step of the experiment. The third, the result of the experiment, and finally, the application of the motor drive. Let's now begin with the first part.
I would like to illustrate this point by showing you what's induction motor and how to control it. Induction motor is the electrical machine that's being used in many industries. There are two main parts. The first, stator. This part has a machine wire to generate electromagnetic field, and the second, rotor, have a role as axle or axis of rotation. In the induction motor drive system, we control the speed of the motor thrust inverters. Inverters is a type of connector which converts the DC signal into AC signal, which is controlled touch PWM signals and form the Raw-speed relationship equation to frequency. So we can control the speed by adjusting the frequency or the number of terminals in the motor, but generally control the speed from adjusting the frequency rather than. It is easier to use by using an electronic circuit. The principle of inverter used in motor control called V per F control. It controls the voltage ratio to the frequency of the motor through the inverter, maintaining the ratio of the voltage and frequency to stabilize it. This enables us to maintain the torque of the motor at a certain speed range. Motor control thrust frequency control has an impact. When controlling at low frequencies, the motor cannot create a magnetic field due to the resistance of the stator coil. The voltage on the array channel is very low. VM cannot be used to create a magnetic field. Therefore, the voltage is compensated during the start, called the voltage boost, so that the motor can create a magnetic field during the start and maintain a constant magnetic field. Next, I will pass you over to Suthat, who is going to present step 4 experiments about induction motor drive with inverter.
Now, let's have a look at this picture. The step 4 experiment. Induction motor driven by the inverter to test the operation of magnetic field and constant torque from measure voltage, current, motor speed, and power at the frequency range 1 to 100 Hz by the device and measurements as shown in picture. This experiment will test drive the motor under the following conditions. The first, in the initial state of the experiment, the motor has a voltage boost of 0% and 20%. The second, for each voltage boost, it will be tested under the base frequency 50 and 60 Hz. Voltage boost and base frequency can be set from the inverter, and on the condition set the torque load at 50%. For each condition of the experiment, voltage, current, motor speed, and power must be recorded when driving the motor in the frequency range 1 to 100 Hz in the table as in this example. Then, take the voltage obtained as the various frequency of each of the above conditions and build a graph of the relationship between voltage and frequency by specifying the horizontal axis is the frequency and the vertical axis is the voltage. Then, take those graphs to analyze how the effect of voltage boosting and base frequency testing affect motor driving, and analyze the magnetic field and constant torque property of the motor. Next, I will pass you over to Suvarnachat, who is going to talk about results of the experiment.
Let's now look at the next slide which shows experiment 1. The base frequency is set at 50 Hz with the voltage boost starting at 0% and 20%. The results are shown in the following table 1. Table 1. Base frequency 50 Hz. According to the data from table 1, we can see the relationship between frequency and voltage in the form of a graph as follows. At the graph 1 shows the relationship between frequency and voltage VUV at base frequency 50 Hz. The graph consists of a blue line and red line. The blue line is the line with a voltage boost of 0%, while the red line is the line with a voltage boost of 20%. The red line will have a starting voltage higher than the blue line. Experiment 2. The base frequency is set at 60 Hz with the voltage boost starting at 0% and 20%. The results are shown in the following table 2. Table 2. Base frequency 60 Hz. According to the data from table 2, we can see the relationship between frequency and voltage in the form of a graph as follows. This graph is showing the relationship between frequency and voltage VUV at base frequency 60 Hz, so it will look similar to graph 1. However, the operating area will change at 60 Hz and voltage will be constant after 60 Hz. According to graph 1 and graph 2, it can be seen that increasing the voltage boost is the way to compensate for the voltage that fell across the stator winding resistor to keep the magnetic field and torque stable. From the both graph, the 0% voltage boost graph and 20% voltage boost graph are paired as follows. The third graph shows the relationship between frequency and voltage VUV with voltage boost 0%. The blue line has a base frequency of 50 Hz, while the red line has a base frequency of 60 Hz. It can be seen that the blue line is steeper than the red line. Moreover, it will enter the constant power area faster than the red line. The fourth graph shows the relationship between frequency and voltage VUV with voltage boost 20%, so it will look similar to graph T. However, graph 4 will have a higher initial voltage than graph T. Next, I will pass you over the Ekalat, who is going to discuss how to apply this knowledge.
Conclusion. Based on above information, we think that the information that we have presented is able to be applied in future work, especially for those who are studying in the Department of Electrical Engineering and may have to work as an engineering in an industrial factory after graduate. Controlling of induction motor is very necessary since the induction motor contain a various mode of operation, and in the each mode can be controlled by different drive method depending on the type of work to be applied. For example, in the industrial factory, where we control the speed of the conveyor to transport items, starting stop motor. From what our group has said earlier, this is an example for drive of the induction motor with an inverter in a mode of a constant torque control, which is the use to control the conveyors. The example shown for general people, air conditioning in our house, and control speed in electrical car use this principle as well.
We are now nearing the end of our presentation. In conclusion, I would like to briefly summarize the main point that our group has covered. In the beginning, we have given you an overview of the induction motors and inverter. After that, we have shown you the experimental procedures. And we have also given you the effect of different base frequency and voltage boost. And finally, we have discussed about the importance of the motor's control in industrial systems. We hope you will find our presentation useful. Thank you for your attention.